What's up guys, it's me, Sir Ernest, and today we're going to talk about collision. So in this lesson, we will allow our system of particles, specifically two particles in an isolated system, to interact with each other. And we already know that for an isolated system, okay, the total momentum is a constant. So if we are allowed these two particles, for example, to undergo an interaction, so let's say a collision, so we know that the total momentum, which is the vector sum of the moment of the first particle before collision and the momentum of the second particle before collision, that would be equal to the vector sum of the momentum of the first and the second particle after collision. So in here the subscript I and F indicate that this is the initial, or that's before collision, and F would be final. So with definition of momentum, this will be equal to m1 v1 plus m2 v2, and that is equal to m1 v1 plus m2 v2, where m1 and m2 are the masses of the two particles, and v1 v2 and this should be u1 and u2 are the initial and final velocities of particles 1 and 2 respectively. So this is a statement of conservation of linear momentum. Now, on the other hand, conservation of energy, or energy conservation, tells us that the kinetic energy of the first and the second particle before collision must be equal to the kinetic energy of the first and the second particle after collision, plus some kind of a energy lost or gain in the kinetic energy, which is a result of the collision. So you will notice here that we didn't include the potential energy or changes in the potential energy because the system is isolated. So from the definition of kinetic energy, this becomes 1/2 m1 v1 squared plus 1/2 m2 v2 squared, and this is equal to 1/2 m1 u1 squared plus 1/2 m2 u2 squared, where again v1 and v2 are the speeds of the first and second particle initially. u1 and u2 are the velocities, or the speeds of the first and second particle respectively, again plus some kind of q. Now let's take note that in terms of momentum, or the magnitude of the momentum of a system, the kinetic energy would be equal to p squared over 2m. For the first particle before collision, this will be p1 over p1 squared, p1i squared over 2m1. Okay, and then the rest of the terms will follow the same form. So this will be p2i squared over 2 m2, and this is equal to p 1 f squared over 2 m1 plus p2 f squared over 2 m2 plus q. Okay, so again, q here is your net or gain in kinetic energy, and this is it is brought about by the collision between these two particles. Now, depends on the collision, this q can have can be expressed in terms of different values. It can be positive, so that means energy is lost. It can also be negative, that means the energy is gained. And lastly, this can be zero if the kinetic energy is conserved. So for example, if q is equal to 0, this means that the kinetic energy is conserved. So this special kind of collision is called an elastic collision. On the other hand, if q is not 0, so that means the kinetic energy is not conserved, we call this an inelastic collision. Now, if q is not 0, this can happen two ways. The first one is if this is positive. If this is positive, your energy is lost. So that means this total energy will be the total energy before collision would be greater than the total kinetic energy of the system after collision, because there's an extra energy that was lost. On the other hand, if q is negative, the energy is gained. So that means the total energy after collision is greater than the total kinetic energy before collision. This is what we call an exergic collision, whereas this would be an endoergic collision. Okay, so that is your an introduction to collisions. Okay, so in the next video, we're going to talk about head-on collisions, wherein the collision happened in one dimension. So what does it mean? So for example, initially, if the two particles are relatively move on a straight line. So the first particle m1 and m2 have velocities. So let's say the velocity the speed of m1, call that v1, is greater than the velocity of m2. So let's call that v2. Okay, during collision, because v1 is generally greater than v2, so that means at some time m1 and m2 will collide. Okay, so this is during collision, this is before collision, and then lastly, these two particles will eventually move maybe away from each other or towards each other, but generally they will move in a different way. So it depends on what kind of collision is given. Okay, so in the next video we're going to analyze this situation, and then we're going to introduce the concept of coefficient of restitution, which generally relates the velocities of the particles before and after collision. Okay, so that's it. That's an introduction, a short introduction on collisions. I hope you learned something today, and I'll see you guys in the next video. Thank you for watching. Bye-bye.